Hello everyone, and welcome to my talk with this pretty long title. My name is Alexei, and here are just a few things to introduce myself. I'm an ex-software developer who is now a full-time application security engineer, and these acronyms. But for what it's worth, I don't consider myself to be a hardware hacker, and today I'm going to talk to you about hacking devices. So let's dive in. A common perception is that application security and Internet of Things are two separate domains. But is this really the case? Consider these two examples. On the left-hand side, I have a classic web application displayed in a browser, and on the right-hand side, I'm looking at web UI from my home router. But from the user's perspective, these two are actually the same. There is some code that runs in the browser, and there is some code that runs on the server side. And who cares where the server is? In terms of requirements, in order to run an application or a device, we need a processor and memory. We need some network so we can send and receive data. We need an operating system, and commonly these days devices run Linux, just like many other servers in the cloud. We might need some services that will help us do whatever we need to do, and libraries that we can build upon, and programming language that we can use to write custom software, and software developers who use programming language and libraries to create great things that will run and do whatever we need them to do. In terms of security, many of us are familiar with OWASP Top 10, which is the list of the top 10 security risks in the web applications. And also a couple of years ago, OWASP published IoT Top 10. And although these two lists are not exactly the same, there is some correlation, like broken authentication and hard-coded passwords, and components with outdated components with known vulnerabilities, and data exposure because of insecure data transfer, and some insecure defaults, and so on. But I'd like to focus on just a couple of things on the right-hand side. The number 2 in IoT Top 10 refers to software that runs on the device itself. And number 3 refers to the software that runs elsewhere, but it's part of the ecosystem so the device could function and do useful things. And as software, these two things can have any of these OWASP Top 10 issues and more. So in reality, in my opinion, a proper diagram should look like this. And I know some of my AppSec friends and colleagues are not going to like it, but I think this is the case, at least from the attacker's perspective. One can attack a device either through an application that runs on it or through some other vectors. Okay, who remembers March 2020? Of course we all do. That's when many businesses all over the world started closing their doors because of the global pandemic. And many organizations and companies had to make very quick changes to go online. And some of these organizations decided to try this new thing for them that was live streaming. So they could broadcast whatever they needed to broadcast and stay connected with their users. And I volunteered to help one nonprofit organization set up live streaming. But first of all, let's discuss what live streaming is. In a nutshell, basically you have your video stream and audio stream in some digital form. And what many people do is they build a general purpose computer with certain software on it. Very popular one is OBS Studio. And this software just converts those streams to proper format, like H.264, and sends that stream to one of or many of these services in the cloud. So that's what I initially built, but the people at that nonprofit organization are not very technically savvy, and this computer was kind of a weak spot. It requires maintenance, it requires somebody to operate it, and so on. So I asked myself a question: is it possible to replace this computer with something else that's maintenance-free? And the answer is yes. I did some research and I found that there are these hardware HDMI encoders that are not very expensive. And I went ahead and bought one. And came in, it had HDMI port, audio port, and LAN connectivity. And it had this nice web interface where I could set up different video settings and also specify this URL for the YouTube ingest server that I wanted to stream to. And everything worked beautifully, like a charm. And this was actually the final setup that I built. Here's my audio mixer and a bunch of cables. And this little box here with the red light is that video encoder. And it worked great, like I said, and everybody was happy, and that's the end of this presentation. No, not really. I quickly realized that I was missing some settings in the device, and in particular, my camera that I was using did not have a very good automatic color balance. So I was wondering if it's possible to modify balance on the device, and I looked in the advanced settings, and although there was a lot of them and nothing documented, I couldn't find the color balance settings. So I thought, okay, maybe this device has some hidden functionality that is not exposed through the UI. Let me look inside. So I opened the box and I looked at the circuit board, and it didn't say anywhere plug here for a free shell. So I just closed it. Again, I'm not a hardware hacker. I don't know what to do with this, generally speaking. So I decided to approach this as a software server. So I quickly ran a port scan, and it found, HTTP server, RTSP and RTMP are the video streaming services that you can use from the device itself. It also had Open Telnet port. I tried a few obvious passwords like root, admin, and none of them worked. All right. I also, explored that web UI a little more, and there was a section for firmware upgrade. And not only it had firmware upgrade, it also had firmware backup. And when I pushed on this button, it sent me this RAR file, which is an archive. And I placed it on my disk, and I unpacked it and extracted a bunch of files. This RAR archive was made on Windows 32, doesn't matter. And here's the content. It had some configuration files, some libraries, Nginx server, the web directory, had a bunch of static files like HTML and CSS and JavaScript. It had some common utilities. It also had password file, but the largest file in this firmware is this one, box.v400_HDMI. And this file happens to be a compiled executable. And I thought, well, if nothing else matches that, this is probably the one that actually runs on the device and controls everything. And I was right. But first, I need to get a shell. So the question is, how do I get there? So I looked at this password file that was in the firmware backup, and it had one-way hash. And I tried to crack it. I used some simple password lists, but I couldn't find a match quickly. And I thought, well, that's not actually a problem, because what I can do is I can replace this password file with my own password file and upload the new firmware and have my own password to log into the device. And that's exactly what I did. I used OpenSSL utility to generate hash for password root. I used Windows RAR utility to repackage the firmware. I uploaded it to the device, rebooted it, and beautiful thing, I am on the device as root, by the way. Great, now that I'm on the device as a super user, I can do a lot of recon. So I looked at, like, for example, what Linux version it runs. And it runs Linux from HiSilicon. HiSilicon happens to be a subsidiary of Huawei that specializes on video surveillance devices and system on chips, like IP cameras and different kinds of video processing equipment. And they have their own Linux distribution. I also looked at the open ports, no surprises here, the same ports that I saw with Nmap, but most of these ports are owned by this box executable, which confirms that this is actually the workhorse that kind of does everything. I also looked at the processes, and I quickly reverse engineered the boot sequence that started a couple of scripts, and then at the very end, as the last step, it started this box executable. So I wanted to have like a clean device when I log in without this application running. So I modified the boot so this application doesn't run, so I could run it myself and play with it. And let me show you how it looks. So here's the, oh, by the way, I need to connect it first. So here's one of these devices that I acquired. It's not the original one. I had several of these. And here's the inside. Pretty neat, but I don't really need it. I just need to connect Ethernet port, Ethernet cable, sorry, and give it some power. Lights up. It's going to take a few seconds to boot. I'm going to put it aside because we don't need to touch it anymore. And let me try the telnet. Okay, it booted. I'm in. Now I go to TMP directory where this box executable lives after the boot. So not only can I start this application on the console, it also prints a lot of useful information on the console, which is very helpful for debugging. Okay, what else do we need? Okay, let me go to the browser and go to this encoder. Of course, I need to provide my credentials. And I'm in, and I see that it spit out a lot of information in the console. Here is the web interface. Cool. What else do I need? I would like to see all the requests and responses going back and forth between the browser and the device. And so I'm used to Burp Suite. This is a tool to intercept HTTP requests. So that's what I used here. And here's one of such requests to get the root page, which just returns some HTML, but you can see that it's using a certain authentication scheme, which is called digest authentication. Keep that in mind. And yeah, I can also run curl against it. But curl did not return anything, so let me look at the headers that I returned. And it actually says unauthorized, of course, because I did not provide my credentials for the curl command. So we'll do it later. Now, let me go back to the slides. Okay, now that I have console, I'm on the device. I also want to take a look at this executable, and it's binary. And binary is not very easy to work with. So we need to reverse engineer it. And this tool came out, was released by NSA a couple of years ago, and I wanted to give it a try since then, and I thought this was a perfect opportunity for that. So I got this tool called Ghidra. I ran it, I gave it that executable file, it analyzed it, and it showed me disassembly, and on the right-hand side, it shows you the decompile, which is basically some C code. And it's a lot easier to read than assembly. So you can make a lot more sense out of it. Okay. And by this time, I was no longer interested in modifying settings on the device. Some voice inside me told me that I should look for vulnerabilities, and I have no idea how I got there. But yeah, I started looking for those vulnerabilities, and the first issue I found was a backdoor in the application. I decided to start attacking it through authentication function. Since I knew that the authentication was using admin for the username and you could not change it, it must have been hard-coded and it was not in any configuration file. So I did a string search in Ghidra and I found exactly one occurrence of string admin, and it's referenced in a couple of functions, and one of them is here, and it does look like the authentication. So we compare a parameter against admin, and then we compare the second parameter against a string. And this string looks really strange. What is this? And it immediately looked at me and said, hey, I'm in the back door. So first of all, let me rename this function to box authenticate. That's what Ghidra lets you do, by the way. It's very useful. You can refactor on the fly. So we first compare the password to new orange and bunch of 8s, and then if there's no match, if there's a match, we succeed and return. If not, then we compare it to the real password. To confirm my assumptions, I entered this password in the browser and it didn't work. And I thought, okay, that's interesting. It should work right here. I also noticed when I was looking at the admin string, in the data section, there was another string called basic. And I thought maybe this application also supports basic authentication. My assumption was right. I did a little bit more investigation, and I was able to use basic authentication, like with this curl command. Great. So now, what if I try this password with basic authentication? And it worked. Cool. So it's definitely a backdoor. Now, I just got some HTML, but it's not very helpful. Another function that I could launch is called getSys. GetSys returns a bunch of system parameters, including the plain text password. And you can just take this password and use it in the browser and get into the device as administrator. So that's a big issue. Another big issue is on some devices, the same password, new orange and bunch of 8s, can be used to telnet into the device. On other devices, it's a different password, or rather a couple others, which are also pretty trivial. So that's another kind of like a backdoor into the device. The next serious issue that I found was path traversal that could be used to get any file from the system. Let's take a look at where this box authenticate is called from. And it's called from this particular function that I renamed to process request, because I realized that it was actually processing all the HTTP requests. And in this function, we see this huge if statement that mentions these file extensions. Basically, it compares a string against, it searches for these extensions in the string. So it does file matching. And if you follow the logic, we'll realize that if a file matches one of these extensions, then it would be served without authentication. So let's give it a try. I'm gonna go back to Burp Suite and pick a file, send it to repeater. And first of all, let me remove all the unnecessary headers just to make it look cleaner. And it still has the authorization header, so it's authenticated. Now let me remove the authorization header and resend it. And it still works. Great. But it's a static file. There's nothing really wrong with it. It's not a secret of information of any kind. But on the console, when it reported the file name, I also noticed these double slashes, which suggested that the developer was using some kind of a sloppy string concatenation. So I decided to play with this a little bit, like removing the slash, and the slash disappeared from here. So it looks like this input is just concatenated with tmp/web or whatever, which means we can do things like traversing. So we can build a relative path that would return us the same result. So we can go all the way back to tmp/web. Yeah. Now, can I get something more interesting, like the password file? No, I cannot. I get for one unauthorized, and that's because the password file does not match one of these extensions. Okay, let's take another look here and notice that they use the method find. And method find of the basic string is looking for a substring anywhere in the string, not just at the end. So they basically using the wrong method, which means that if there is one of these substrings anywhere on the path, like say here, it would match. So let me try this. And instead of unauthorized, we get not found, because such file does not exist. Well, if only I had a directory with one of these patterns in its name, then I could traverse from that directory anywhere and get any file. And apparently on devices from one of these vendors, there is such a directory. So let me open another telnet session and look for, search for a directory with JPEG in its name. And here is such a directory. And this is the only one that matches. Now, using this, I can build a relative path all the way back to the root and descend down to any other file. And now if I tag this to my HTTP request, I should be able to get any file from the system. And it totally worked. I could get the password file from the system unauthenticated. But it's not the most interesting file on this box. The more interesting one is called box.ini, which, among other things, contains plain text administrative passwords, which you could use and then for the admin access on that device. Let's continue playing with this device, or rather with this application. The next issue I identified was unauthenticated file upload that would lead to remote code execution. Going back to Ghidra, I decided to just review the entire function that's processing requests to see if there's anything else interesting. And right off the bat, at the very top of the function, I saw this compare against multi-part form data. And again, if you follow the logic here, we would see that if there is a match, then the function would be called that would process multi-part data and just return HTTP OK. So yeah, that looks like another unauthenticated process. So I'm going to rename or refactor this function to box multipart for convenience. Cool. Now, where is form data used? Let me go back to my verb history and search for multipart. There's a couple of post requests here, and the first one of them is a logo upload. Here, that's what I tried on the device. What happens is on this device, you can upload a logo that would be overlaid on top of your video stream. It could be like maybe your company logo, right? Let me try it real quick. Upload successful, and here is a message on the console. Cool. Now, my suspicion is that this is unauthenticated. So I'm going to send it to repeater again. And remove the authorization header. And press send. And it returned HTTP 200. Okay. Okay, well, this is really unauthenticated. Well, cool. You can upload logo and do some harm, but what else can you upload? And the other thing that you can upload is actually a firmware update, believe it or not. So the up.bin or up.rar can also be sent completely unauthenticated. So that's a pretty serious issue. You can basically create your malicious firmware, push it on device without any credentials, and have it run it. Now, the problem is, in order for this firmware to run, somebody needs to reboot the device. And well, like administrator pushing that button in the web UI. And that's not what something the attacker would want. Attacker would want to execute the code right away. Let's take a look and see what else can be uploaded. Maybe there is more. I see on the console this message with file name colon, and I'm gonna go to my favorite string search in Ghidra and search for the string. And it does find an occurrence of it, and it's referenced in this function. I'm gonna call this function box upload, because that's the function that processes file upload. As you can see, it's called from box multipart, which in turn is called from box process request, all authenticated again. Now, when I scroll down this function, kind of looking at what's interesting here, I see a list of these different compares. We see our familiar load file, box.ini, and some others. So this is basically a white list of allowed file names that one could upload to the device. And one of them is uk.rar or uk.bin, and it's not the up.rar, not the original firmware upgrade. It's something else. So let me see where uk.rar appears in this executable. And it is mentioned in another place that reads as soon as the file is uploaded to the device, it's unpacked, and then uk.txt that's supposedly present in this file gets executed by shell. So that's your instant code execution that we actually need. So in other words, we need to build a uk.rar with uk.txt inside that has some malicious code. And that's what we're going to do right now. So I have this file, uk.txt, that has a single command with netcat listener. By the way, netcat is present on the device, very convenient for a hacker. Okay, and make sure I use the correct rar command. I need to use the version to downgrade the archive version. Okay, now I have this rar file, and I'm gonna send it to the device using curl. So I'm sending the curl command, which is a form with a single parameter with content of this file, to encoder. And executes, the file gets extracted, and ideally, technically, I should have the process, and I do have the process that's running on the device, listening for incoming connections, and I can totally connect to it. And I'm a root on the device, and I own it. I can do whatever I want. And that's basically it for this vulnerability. Now, the device is going to reboot automatically, but that's okay. Going back to my presentation. But this is not all. Another distinct issue with this file upload is command injection. Let's see what else happens there. If we go back to see how uk.rar is processed, we'll see that it's not the only file that gets special treatment. PNG files are also processed in a certain way. We build a command to run this utility to convert PNG to BMP. And one of the parameters here just accepts user input, which is the file name. And this file name comes from the HTTP request from here. By some trial and error, I found out that this name has to begin with logo and end with PNG, but it can have anything in between, like, I don't know, whatever, including semicolons. And if you put a semicolon here, it should become part of the command that runs and execute it. And you'll see that foo is not found. Of course it's not. But what is found on the device, as we know, is netcat. And we can totally execute it. And now if I look at the processes on the device, I'll see that my netcat listener is here and alive, and this is actually the full command that got generated with our injected input. And now, again, I can connect to the device using netcat and do whatever I want. Up until now, I was not looking for any specific vulnerability types. I just happened to find some backdoors and injections and so on. But there is a certain category that I wanted to specifically target in this application. With C and C++ programs, if you're not careful, it's very easy to cause a buffer overflow. And I thought there must be at least one buffer overflow in this application. And did I find one? Well, yeah. I was looking for functions like sprintf, which takes input and combines it into a string and puts the result into a buffer. With these kind of functions, if you're not checking all the length, it's very easy to get buffer overflow. And I found several occurrences of these issues, and this is just one of them. There's a bunch. But in this particular case, we are dealing with building a response for RTSP. RTSP is a video streaming protocol. So you basically can connect your video player to this device and get video right off the device. It's a text-based protocol, just like HTTP, and it's using a sequence number here.
But in this case, the device, this application does not really care about the sequence number. It just appends whatever the user gives to it back to the response and reflects back to the user. Let me show you how it looks. Since this is a text-based protocol, I can just telnet to proper port, which happens to be 554. I had to study this protocol a little bit to build this proof of concept. So this is just one command, teardown, and the sequence number is 1, and I just get 1. But if I give it anything else, including any string, I will get that any string back. To cause buffer overflow, I built this request, teardown command with sequence number with very long value. But before I send it to the device, I want to do something else. When we are debugging stuff like buffer overflow, it's very helpful to have a debugger. And the beauty with Linux is you can use all the standard tools, including GDB. So I have uploaded a GDB server to this device, and I'm going to run it. It attached to this process of my application and listening on port 2345. Now, in another window, and I have to copy and paste these commands because they're pretty long, I'm starting my debugger on local machine. After I start it, I need to connect to that remote server, and I have all the nicely colored information here. As you might have noticed, I am not using vanilla GDB, I'm using Jeff extension. And that's a pretty cool thing to have if you're doing reverse engineering. It just makes things a lot more easier. Cool, now I have debugger, I can see what's going on, and I'm going to send that huge request to the application. And something happened here. I got segmentation violation. And as you can see, those A's that were in the sequence value are placed all over the place across multiple registers. So it's definitely buffer overflow that can cause the application to malfunction and to go a different route. It definitely causes a crash. So the big question is, can I get code execution with this? Because with many overflows you can. And I went into a very deep rabbit hole, and after several nights I concluded that it was not possible in this case, mostly because of ASLR. And at the time you get overflow, the application is very unstable and is likely to just reboot or crash. And you could not try multiple things to get around ASLR. But if you combine this with the file disclosure, you can get your base address to go around ASLR through file disclosure. So that's a possibility. But even without that, the sole purpose of these devices is to serve video reliably. And if an attacker can crash it easily, then that's a big issue. That's basically denial of service. In summary, we have several vulnerabilities that I'd like to put in 3 categories: red, green, and yellow. The 2 issues in the red category are the intentional vulnerabilities. So somebody actually programmed that backdoor on purpose, and somebody decided to leave the telnet open with a trivial password. This is not good and completely unacceptable. The issues in the green category are coding mistakes without any malicious intent. We all make mistakes, and that's okay. We just need to learn and don't repeat those mistakes again. Now, this issue with unauthenticated firmware upgrade, it is possible that it's bad coding, but it's also possible that it was there on purpose, so the vendors could update firmware without any credentials. I don't really know. But these devices are behind net and firewall, right? Well, hopefully, most of them are, but Shodan finds almost 1,000 of such devices on the open internet. When I did my research initially about a year ago, Shodan found only between 300 to 400 of these, and now the number has tripled. It's not a huge number, but it is significant, and many of these devices could be still vulnerable. I decided to disclose my findings to vendors, and I got all sorts of interesting communication with them, from no response to some automated response to misunderstanding, like somebody telling me that their devices are meant to be used by home users and not security companies. And even some people thought that I was trying to damage their company's reputation, and they mentioned legal action against me, and that was not something that I was interested in. So I was pretty discouraged by this. And I talked to my ex-coworker who had some experience with third-party disclosures, and he suggested that I get in touch with CERT Coordination Center at Carnegie Mellon. These guys help you with third-party with coordinated disclosures. They do a lot of legwork, contacting the vendors, following up with them, building, publication and everything. So it was great. Overall, I identified 11 vendors, and I confirmed that 3 of them were vulnerable. I had those devices and could test them. 8 others were likely vulnerable based on the information I could find online. Unfortunately, only 2 vendors responded to our initial requests. Too sad, but okay. Meanwhile, I've got 6 CVEs assigned, and eventually this got published. A couple days later, Huawei issued this statement saying that they produce SDK and chips and SDKs, and all user space programs are built by downstream vendors. Meanwhile, the Register picked up the story and published the article. And a couple of weeks later, one of the bigger vendors for these devices, Opre, published this advisory, and they acknowledged all the issues and said that they're going to fix them. And they also mentioned the name of the developer for the application, New Orange. Remember what the backdoor password was, right? It was New Orange and bunch of 8s. Totally makes sense. I also like how they use the word maintenance instead of backdoor. Of course, it's all maintenance. Fast forward to July 2021. I went ahead and ordered a few of these devices again to see if the issues have been resolved. I got these encoders from 3 different vendors this time. The first one that came in was from JTech Digital, and it had the telnet port closed, good, but the application was not fixed at all. It still had all these vulnerabilities. I went to the vendor's website and downloaded firmware, and it was still the old one with all the issues. The 2 other vendors, URay and iCV, actually had the application fixed, but the telnet was open with the trivial password. I don't know why they decided to keep that open. Other vendors, I did some online research. I did not have the devices, but I downloaded some firmware where it was available. Some of that was fixed. Other still had obvious issues, but it's difficult to tell how many got the fixes out, and some of them didn't even have anything for download. So it's a mixed bag, but for the most part, I believe that the developer for the software, New Orange, they address the issues. It's just a matter of pushing those fixes downstream to all these different vendors. Takeaways from this presentation. IoT devices are computers, and computers run applications. And many of us here know how to make applications more secure, how to find vulnerabilities and address them. So let's do it, because remember, the reality is this. You can apply your knowledge to other areas and make the world more secure. The complete write-up for this research is available on my website. And also, if you have any of these devices and want to run a quick test, the exploit scripts are on GitHub and ExploitDB. I would love to hear from you whether you like this presentation or not. If you have any questions or suggestions or need help, please let me know. I'll be happy to chat. Thank you very much for attending this talk.